The geology of Connecticut, it's cool to look at it, but even more than being kind of cool and complicated, it really tells the story of a very fundamental set of tectonic processes. Right here where we're standing now, we're not at a plate boundary today, but in the past, Connecticut has lain on a subduction boundary where there's an oceanic plate diving beneath a continent, and then later on, a site of continental rifting where the supercontinent Pangaea was pulling apart. Connecticut sort of allows us to have this natural laboratory where all of these processes have operated in the past. It's all exposed in the surface geology. And then we want to use seismology to study the deep structure and ultimately to learn a little more about these very fundamental tectonic processes. So what we're doing with SEISConn is we are installing a set of seismometers right here in a linear transect across the northern part of the state. And the idea is to sample as many of these geologic units and features as we can with a 15-station array. And then to ask, here at the surface, we see this very complicated geology. What does that look like deep down? What does it look like in the crust and the uppermost parts of the mantle? How have the deeper parts of this system reacted to all of these past tectonic processes? The way this works is we can use our array of seismometers and measure energy from earthquakes that are very far away. And so what happens is you have an earthquake, the seismic waves propagate through the body of the earth, they go through the mantle, through the core sometimes. And so the energy from these waves has passed through the Earth's interior in a way that we can't do by direct sampling. We can only drill a few miles down. Seismic waves, however, can pass through the Earth's interior. And the way this works is we can apply a suite of different imaging techniques to use those waves basically as a source to do imaging in a way that's very similar to a lot of the medical imaging that we're familiar with. We have a big team of students from Yale University that are working with us. So we have both graduate and undergraduate students who are involved in the fieldwork. And that's a really great opportunity for our students because an enormous part of being an earth scientist is getting out into the field, seeing the rocks, seeing what you're studying, and getting some experience collecting the data that you're later going to work on and analyze. So this complicated geology, it's really important because it tells the story of these fundamental tectonic processes that have operated in the past. And that's really what we're trying to get at with the SEISConn projects.